Okay, so today we're going to be starting on page 115, and it's going to be called Coordinate Geometry Proofs Day 1. So our objective today is to apply coordinate geometry and integrate knowledge of quadrilateral and triangle properties to prove geometric properties on a coordinate plane. So today in our notes, we're going to be proving a shape using coordinate geometry. So some things that we should know. To prove sides are congruent, we're going to use the distance formula. To prove perpendicular or parallel lines, we're going to be using slope formula. And to prove lines bisect each other, we're going to be using midpoints. We're going to show that midpoints are the same. So for our first example, we want to find the fourth point of the square with vertices A 0, 6, B 3, 2, and C 4, 9. So the first thing you guys want to do is plot your points. Okay, sorry for the jump in video, so we're going to get back to plotting our points.
Monica Stento, please call main office. Monica, call the main office.
So the first thing we want to do was plot our points, and then now we're going to find our slope of line AC. So we're going to have 9 minus 6 over 4 minus 0, and we get 3 over 4 as our slope for AC. Now our perpendicular slope would be the negative reciprocal of 3/4, which is negative 4 over 3. So we're going to apply our perpendicular slope at point C. So we're going down 4 and to the right 3. And we'll draw a perpendicular line. Now, at point B, we're going to apply our parallel slope of AC, which is 3/4. And we're drawing our parallel line. And where our parallel line and our perpendicular line intersect, this is going to be our point, which is point D, and that's at 7.75. So our fourth point is 7.5. So now we're going to go on to a second example. So for this one, we're going to find our third point of the isosceles triangle with vertex A and point A, which is -5, -4, and B, which is -3, -8. So the first thing we're doing is plotting our points again. Point A. And point B. So we know our vertex is A. So we want to find our slope of AB. So we have a -8 minus -4 over -3 minus -5. And we get -4 over 2. So now we can create our right triangle and apply the Pythagorean theorem. So we have to see which vertex we're going to use to place our new right triangle. So we know we're going to be choosing vertex A because it gave us vertex A, and we know for an isosceles triangle, our congruent sides are, our vertex is between our two congruent sides. So we're going to have a right triangle going. So we can use our slope, and we're going up 4 and then over 2. This would be our new triangle. So this can be a possible point, or we can go down 4 and to the left 2. And this would be our other right triangle. So we can have a point. Our point can be C, which is -3, 0, or we can have our point at -7, -8. So we'll make a note down here. Just for an isosceles triangle, our vertex is in between the two congruent sides. This is for isosceles triangle. So now we're going to move on to our last example. For this one, we're going to determine the most specific name for the triangle ABC that has vertices A, -3, 1, B, -2, -1, and C, -2, 1. So again, we're going to plot our points first. So we're at A, which is -3, 1, -2, -1, and 2, 1. We can draw our lines to make our triangle. So we want to know what type of triangle this is going to be. So first we can use our slope formula, and you want to see that, to prove that two sides are going to be perpendicular. So we can do that by finding our slope of AB and then our slope of BC. So we have a slope of AB, we're going to have a -1 minus 1 over -2 minus a -3, and we get -2 over 1. And then we're going to have for our slope of BC 1 minus -1 over 2 minus -2. And we get 2 over 4, which is 1/2. So we proved that two sides are perpendicular because these are negative reciprocals of each other. So this is looking that it's going to be a right triangle, but we need to make sure that it's not isosceles. So we need to see that all sides are not equal. So we can do this by looking at our picture here. So we prove that this is a right triangle, but we need to make sure this is not isosceles. So by looking at our triangle, we know that AC is going to be our longest. So AB and BC can't be equal to it. So we know I have to see that AB and BC, by looking at it, we see that they're not the same length. So since none of the sides are the same, then we know that it can't be isosceles. So this has to be a right triangle. If you didn't know this by looking at our triangle, you can also use the distance formula for each length to see if they're the same. If they're not, then we know that it's not isosceles.